All right, this is section 11.1, which is known as the fundamental counting principle. It's very, very easy. And just as an introduction into what we're doing in chapter 11, we move away from like big calculations and we move closer to more probability and statistics. And so if you look at even chapter 11 in general, it's labeled probability, statistics are entitled probability, statistics. It's very, very easy. It's kind of like a very superficial layer into the study of those two areas. So what's going on here? The fundamental counting principle is kind of a way to figure out all of your possible options. Let's take a look here. A restaurant offers 9 appetizers and 6 main courses. In how many ways can a person order a 2-course meal? There are blank ways. Okay, so what you see in the fundamental counting principle, which we'll call FCP, okay, is you want to know how many possible ways, how many possible, I don't want to use the word combinations because it's used later in section 11.3, but how many possible ways can you make a meal or a 2-course meal when you have 9 appetizers to choose from and 6 main courses? Does that make sense? Okay, so in order to figure out how many, you simply, it's very simple, multiply all your options. In other words, we have 2 categories here. So if we have category 1 in this problem, we look at how many options we have there. We have category 2, that's our main courses, how many options are there. If there was a category 3, like a dessert, you would multiply that. For now, we only have to multiply the appetizers and the main courses. What's the answer? Answer? Come on.
54.
There you go. So that's it. Does that make sense? Okay. So now let's take a look at this one. A popular brand of pen is available in 10 colors and 2 writing tips. How many different choices of pens do you have with this brand? So in other words, we have a category of colors. We have a category of writing tips, maybe fine point, medium point, you know, a thicker point, whatever. Answer? 20. That's it. It's that simple. Does that make sense, everybody? Okay, a lot easier than what we just came from. A sales rep can take one of 3 different routes from city B to city E. Any one of the 7 different routes from city E to city G. How many different routes can she take from B to G and then G to E? How many categories do you really have here in this problem?
30.
Actually just 2, right? You have a route 1, which is B to E, right? And then you have another route, E to G. Does that make sense? So answer is what?
21.
21. Okay, that's it. Now, we see for the first time 3 different categories. Do we change anything here just because we have 3 categories? No. Now, we just multiply category 1 by category 2, then follow that up by multiplying by category 3. Does that make sense, everybody? So this is super, super easy. If we have 3 drinks to choose from, 5 different sizes, and 8 flavors, we need to take 3 times 5 times 8. Somebody have an answer for that? 120. Good. Does that make sense? Pretty easy. Not bad at all. Okay, now, is this a big deal here?
Nope.
No. Does it matter that they haven't told you how many items are in each category? No. Does it matter that there are 4 categories? No. What do we do with it? First, we need to count up how many are main courses. How many are there?
5.
Careful. 4, yeah. Easy to see pork roast and think pork comma roast. It's not, right? So pork roast is one possible selection from the main course category. And there are 4 possible selections. How about vegetables? 4 as well. How about beverages? 4. How about desserts? 4. There just so happens to be 4 in each of these 4 categories. Does that make sense? Not a big deal. What are we going to do with each of these? Multiplying 4 times 4 times 4 times 4. In other words, 4 to the 4th power. Just so happens to be that here, right? Anybody got an answer for this?
256.
256. That's it. So you don't necessarily have to have only 1 or 2 or 3 or in this case 4 categories, right? You can have any number of categories, any number of items within each category. It just so happened that this one had 4 in every single category. Okay? Not to be confused that it always has to be that. Okay? Let's take a look at this next one. A person can order a new car with a choice of 7 possible colors. What's our first category? Colors. And number of options? 7. Good. With or without air conditioning? Boom, stop right there. What's our next category? AC. How many options? 2. With or without AC gives you 2 options, right? With or without automatic transmission. Stop right there. What's our next category name? The transmission. Right? How many options are there? 2. Manual or automatic. Does that make sense? Okay. With or without power windows. Okay. Windows. 2 options there. With or without CD player. Who even uses that in their car anymore, really? You know, I just actually broke out my CD player in my car for the first time in 5 years. I actually put a CD in there. Since I bought that car new, maybe you guys do use it, but I don't.
I got a new car a few months ago. I haven't used it once.
They still come with them, right? It's crazy. Those are definitely going away. In how many different ways can a new car be ordered with regard to these options? So we don't have any more, right? 1, 2, 3, 4, 5 categories. 7 times 2 times 2 times 2 times 2. Was it 112?
Yep.
Okay. There you go. Okay, let's take a look at this next one. You are taking a multiple choice test that has 5 questions. Each of the questions has 4 answer choices with 1 correct answer per question. If you select one of these choices for each question and leave nothing blank, in how many ways can you answer the questions? How many categories are there technically?
3. 5 questions, 4 choices, but 1 correct answer.
Now think of, I'll give you a hint here, maybe the hint just straight up gives it to you. Your choices are your options. What are the choices tied to?
You have 4 options per question.
Right.
So you're actually, so what? You actually have what, 32? Oh, I'm sorry. I'm looking at.
That's okay.
My numbers are different.
So, let me see if I can say this without giving it to you. I don't want to give you the answer.
Well, you have
Exactly.
you
So,
have 4 answers with 5 questions, so it's going to be 4 to the 5th power.
right, because every question is its own category. Does that make sense, everybody? And so within each question, you have 4 choices. Does that make sense? So it's 4 times 4 times 4 times 4 times 4. Does that make sense, guys? So when you get to question 7, or when you're dealing with a test option thing, every question on your test is its own category. Does that make sense? Okay, every question is like its own category, so this is 4 to the 5th power, technically. Or 4 times 4 times 4. Answer?
1024.
Okay. Maybe. All right, let's take a look at this next one. License plates in a particular state display 3 letters followed by 3 numbers. How many different license plates can be manufactured for this state? So, how many different categories do you have technically?
6.
6. Letter, 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 right? Number, number, number. 6 different categories to make your license plate. Does that make sense? Right? Now, if the first 3 are letters, we have to find out how many options we can choose for these, right? How many letters are there to choose from?
24.
How many letters are there in the alphabet? 26. How many numbers are there if they're single digits?
10.
0, right? 10, right? You get to count 0 through 9. Does that make sense, guys? Okay, and then we just multiply that. Anybody got an answer for that?
17,576,000.
Like that?
No,
17,576,576.
76.
Like that?
Yes.
There it is. Does that make sense, guys? Does that not make sense?
No, I'm sure it does.
No, not that, not that you're sure it does. What's the question? So you have a license plate with six places on it, right? The first 3 places have to be a alphabet letter. The next 3 places have to be a number. So if your first place in your license plate has to be a letter, how many choices do you have there?
Okay,
26.
totally get it.
Now, what you may be thinking is, well, what happens if I use one of those letters? Does it knock it down? No, we're not there yet. Okay, that's permutations and so on. That's coming up. This, you can reuse a letter, right? So if your first letter in your license plate, if it's A, it can also be A for your second digit or your second place, right?
Right.
So does that make sense, everybody? Okay, you can reuse stuff. That's part of your question. Okay, let's take a look at this next one. A stock can go up, it can go down, or stay unchanged. In other words, how many options do we have?
3.
3. There are 3 options for a stock. How many possibilities are there if you own 10 stocks? So, how many categories do we have?
10.
10 categories, right? And each category has what options? 3 options. Go up, go down, or stay unchanged. In other words, it's 3 to the what power? 10. So whatever 3 to the 10 is, that's how many ways your stocks can go.
59.
I'm not going to enter it. We're all good.
49.
Okay. So let's take a look at this next one. So 3 to the 10th was that. How many 5-digit odd numbers are possible if the leftmost digit cannot be 0? Let's take a look here. So if you're doing a problem like this, what you should do first is lay out your categories, right? How many categories do we have? How many categories, not options, categories?
1.
5.
5. You're dealing with a 5-digit number, right? Meaning that you have a category for each of the digits in your 5-digit odd number. Does that make sense, guys? The leftmost digit cannot be 0. Which one's the leftmost digit? 1, 2, 3, 4, or 5? 1. If this can't be 0, it cannot be 0. How many options do we have here?
Well,
9 times 10 times 10 times 10 times 10.
Okay, hold on. Let's deal with this one. How many options do we have here?
9.
You have 9. Why am I not counting only the odd numbers here?
Yeah, why aren't you?
Because the first digit in in an odd number doesn't matter whether it's odd or even.
Oh, okay.
Does that make
That
sense?
does make sense.
What does matter when you're deciding odd or even is your last digit. Isn't that true? The last digit makes a difference. So how many options do we have in category 5 if the last digit has to be an odd number?
5.
1, 3, 5, 7, 9. You have 5 options here. Now, do these matter?
Nope.
So how many options do we have on these? 10 for each of these. Because your second, third, and fourth digits can be any numbers you want. So long as if you're building an odd number, your last digit has to be odd.
How did you get 5 under that again? Under the last, under 5, how did you get 5?
So how many numbers are odd
Oh,
from,
okay, you counted them on your fingers.
right,
Okay.
1, 3, 5, 7, 9. 5 options for that. So as an example, your number could be 4, 2, 2, 8, but it has to end in N, what? Odd number, 3. That's an example of one of your options. Does that make sense? 42,283. Another option, 3, 5, 6, 7, 7. Isn't that another option? But it just can't be what for your first digit?
0.
0, and your last digit has to be odd. Does that make sense, guys?
Zero would make it a 4-digit number instead of 5.
Exactly, it would make it a 4-digit number if that was a 0. So, what's the answer to this problem?
45,000.
That's it?
Yeah.
Okay. Perfect, good job. Okay, I'm gonna skip 11. You guys can answer that one yourself, okay? Let's take a look at this one. Okay, it says in a different plan for area codes, the first digit could be any number from 1 through 6. Now, area codes, what are area codes? Are those zip codes, or are those 5 digits, or are those 3 digits? They're 3, right? That's you're thinking zip code, right?
Yeah.
So area code on a phone number, right, would be the first 3 digits. Everybody agree? Okay? So here we go, back to our topic. The first digit can be any number from 1 through 6. So your first digit of your area code, telephone area code, is a number from 1 through 6. How many options do we have there?
6.
6. 1, 2, 3, 4, 5, 6. 6 options. The second digit has to be 4, 5, 6, or 7. How many options there? 4. And the third digit could be any number except 0. How many options there? 9. 0 would make it 10. With this plan, how many different area codes are possible? 6 times 4 times 9. Answers?
216.
216.
The age I want to live to.
All right, I'm going to skip 13. I'm going to leave that for you to do, okay? So I've done almost every question here. That is it, okay? For that.